signature. This feature already exists in VB.NET today, and what we're seeing is some convergence of the major features of C# and VB.NET, and certain key features of C# make their way into VB.NET and vice versa, and we'll see more of this as we move forwards. But let's define ourselves a little method here. Let's have an add method that takes two integers and simply returns the sum of the two. Now clearly, if I want to call that method, I need to pass both those values. Let's just have a console.readline to stop us dropping out. I need to pass both those values as things stand. What I can do to take advantage of optional parameters is to define a default value. So let's say that my default value for B was 1. So I've now got a method where I can either add two integers or I can increment an integer. What I can now do is to remove that second parameter, and I still have a valid call to that method. And in fact, if we look at the method signature here, you'll see that the second parameter is in square brackets. It's truncated slightly because I'm on such a large font size, but you'll see it's in square brackets, indicating that it is an optional parameter. So I can either call the method with passing one parameter, or I can call it passing in both parameters. Oops. Let's just build, make sure that builds. So we're calling initially with the value of 1, the default value 1, so we should see 2, and the second time we're adding 1 and 2, so we should see 3. Let's run it and see if that is indeed the case. And sure enough, we can see we get a result of 2 and 3. Now, there's a couple of things to bear in mind here. One is that what I can't do is define optional parameters in the middle of a parameter list. So if I try and build now, you'll see that we get an error saying optional parameters must appear after all the required parameters. So that's not a legal thing to do, but we can of course change C to be an optional parameter, and that should build just fine. So all the optional parameters have to be at the end of your parameter list. Now the other interesting aspect to this is around method signature resolution. So which method do we call for a particular argument list? So let's take our method here, try and illustrate this. And let's monkey around a little bit with the signatures. Oops. Let's remove the optional parameter from these two, the second optional parameter. Let's change the type of this one to be a double. And we'll need to change something. Oops, change something about this. Let's just return a double. So what do we have now? We've got one method that has a single required parameter. We've got one that's got a required integer parameter and an optional integer parameter, one that's got a required integer and an optional double, and the original one that has a required integer and two optional integers. Now if we look at our method calls, we'll see this one actually matches all of those, as there's only one required parameter in all of them and it's an integer, and this one matches 3 out of 4 of them. So what's interesting is which methods actually get called. Let's just set a breakpoint on each of them and run. And we'll see that in the case of that first method call, we get called in this method here with the single required integer parameter. And for our second method call, we get called on the second method with the single integer required parameter and the single integer optional parameter. Now, why is that the case? There are some strict rules governing this, but in essence, the matching method signature with the fewest optional parameters being omitted will win out. So in the case of this first method call, the reason this method wins is because we have a matching method signature and no optional parameters are being missed, whereas if we were to match against this signature, well, we have a matching signature, but this optional parameter is missed out, so it loses out to this method here where we have a perfect match. In the second case, where we're passing integer 1, integer value 2, we've got a match on all three of these potentially. This signature loses out because we are omitting one more optional parameter than we are in the other two, and normal rules apply, so this signature loses out because we're having to convert from an int to a double, whereas in this case we already have a signature that has the two integers that we are passing as parameters. So there's a clearly defined set of rules. It's kind of difficult to explain them in a verbally here, but you look for matching, all the matching signatures, and then you look for those that have the fewest omitted optional parameters, and of those you pick the one that is the best fit to the types that are being passed under the normal rules.